Hi, in this video, I'm going to show you how to plot lines in Desmos, but I'm going to focus more on how to plot lines in R. I like to visualize mathematical expressions because it helps me understand it better. I have a hard time relating to an abstract equation, but whenever I can see it plotted, it starts to make a lot more sense to me. But let's see. So it's pretty easy to do in Desmos using the graphing calculator. So here's a line, 2x plus 0.5. Let's see. We can do all sorts of lines like this. Let's do an S curve. Let's do 1 over e to the negative. And it doesn't matter for our purposes what these might represent in your particular application, like whether this is a regression line or whether you're trying to do some logistic regression. Don't worry about it. All that you really need to know in this particular context is that these lines describe these equations. These equations describe these lines, so we're going to be able to replicate this in R, this same effect of plotting lines. Let's make that a steeper gradient. Okay. Then let's just add something weird, like let's make it. There we go. That way they're all hitting at the same y-axis or y-intercept. And let's give it more oscillations. There we go. Okay, so don't worry. It doesn't really matter what is going on here. What matters is each of these equations corresponds to a different line, and graphing it can be helpful for understanding it. And I just did it very quickly in Desmos. Now I'm going to show you how to do the same sort of thing in R. Okay, so the core concept here is going to be that we're going to plot, or sorry, we're going to create a sequence of coordinates. Basically, we're going to get a vector of numbers for the x-axis, and it's just going to be, like in this case, we'll do from -2 to +2 by some small increment, like 0.01. And then we'll get another vector, which is the corresponding y values. So whenever x is 0, the value of y is 0.5 for all three of these lines, actually. When x is 1.324, the value of y is 0.665, and so on. So we just need to get those corresponding values, which is actually easier than it might seem. We don't need to figure out all of these coordinates. We can just use an equation like we did in Desmos. So let's see. First of all, let's plot y equals 2x plus 0.5. So first, we're just going to define x. We'll make this a sequence of numbers from -2 to +2, and let's go by 0.01. That should create like 401 values if we include 0, which we did. Okay, and then our y, our first y, is going to be equal to, we can just use the equation 2x plus 0.5. So y1 gets 2 times x plus 0.5. Okay? And whenever I do this semicolon, all that's doing is it's making it so when I run the line, it computes that, and then it also does this. And it's just going to print y and show me what I've just done. And so I got those values. And there are, is that the right number? No. What have I done wrong? What have I done wrong? How many values are next? There should be 401, 2 times x plus 0.5. Oh, this is from this is from some other thing I did in the past. I use the variable names x and y a lot. So this is why. So R can't read your mind. It can only obey exactly whatever you said. So I just created 401 values that are y1, and then I asked it what y is, and y is some, I don't know, something I previously defined. So I actually want to know, what is y1? Okay, there we go. And that is, there should be 401 of these. I can actually see it down at the bottom, but there you go. Okay, so now we're just going to plot y1 against x. So we could do this in ggplot, but I'm not. I usually, if I'm just plotting a line, I'm not talking about a line graph with actual data, but just like lines that are described by equations. I just want to quickly see it as though I were drawing it on a whiteboard. I just want to pull it up real quick and get a sense of what it looks like. So I'm not going to do a bunch of confusing advanced plotting. I'm just going to use base R and say plot y1 as a function of x. That's the tilde symbol. So y1 predicted by x. Let's see. So I had the line here is purple. So why don't we make the line purple? Let's say the color is, does it recognize purple? Yeah, it's got purple. Okay, and let's just see what we get. Okay, so first of all, it's plotting all of those as dots. I want to see that as a line. So I'm going to say the type is L. Type equals L, and that's a string for line. Okay, so now we've got a line, and I'll make it a little bit thicker. So LWD equals 2, just because the line here is a little thicker. Now, it may seem like the gradient of this line is steeper, but that's just an artifact of the way that this plot is scaled compared with how this is scaled. This ranges from -2 to 4 and -2 to 2. This one is going from 0 to 2 and -2 to 3. It's not on the same scale. That's why it appears to be different, but it is the same equation. Okay, now let's go ahead and add x and y axes. We can use AB line. This is a function where we can add a line to a plot, and we'll say horizontal h equals 0. So the horizontal line, a horizontal line at 0. Bet you can figure out how we'll get a vertical line. Yep, AB line, and then the argument is v equals 0. Excuse me. Okay, so now we've got x and y axes. Let's see, what else did we plot? We also have a black line here, which is kind of an S-curve. Let's get that. Okay, so we can keep the same values of x because we still want that sequence going from left to right, but we need to change what y is equal to. Now it's going to be equal to what? We've got 1 over 1 plus e raised to the negative 5x power. Don't worry about all that. Okay, let's just follow that equation. So we've got 1 divided by. Because this is going in the lower part, in the denominator, we're going to put what happens next in parentheses. We have 1 plus. Now to get e, which is a constant, it's this is how you could get e, but I don't like writing all that. And also e for me isn't used for anything, so I always set this equal to e. I say e is equal to that. Now, whenever I type e, I get that constant. But if you don't know what e is, that's not really the point here. So it's 1 plus e raised to the, how would we do this? I think we said -5 times x. All right. I think I did this correctly, but maybe I screwed it up. Let's find out. So to add lines here, we can use the lines function. and we can say y2 predicted by x. And I'll go ahead and say the type is L. I'm not going to change the color because it should be black by default. One. Okay, there we go. Now we've got our S curve has been added to the plot, and you can see it's doing the same thing that it was doing right here. Okay, now let's add that sine curve. Plot the sine curve. All right, y3 is equal to, what did I use? Sine 5x over 2 plus 0.5. Okay. I think sine is just a function. Yeah. Okay. So we can say sine of 5 times x. Remember, 5x wouldn't be recognized. You need to use 5 asterisk x for 5 times x. Then I said divided by 2 plus 0.5, I think. Let's just quickly run this and see if I did it correctly. So let's add more lines. Now we're going to predict y3 using x. Type is line, width is 2. And this one is red. I made this red for whatever reason. So the color is red. Okay, there we go. So we've just replicated it. We've got all 3 lines all intersecting at the y-axis at 0.5, and we've replicated that in R. Okay, this was just a quick demonstration of how you can do what you can do in Desmos. You can also do that in R. And I think it's useful when you're trying to understand an equation or really any concept to try to break it down in this way, try to represent it yourself. If you, maybe this is really geeky, but if you see someone plot a line in a video or in one of your textbooks, see if you can recreate that line yourself in R, because if you can, you're just on a completely different level of understanding of what's going on. So I think it's really helpful, but maybe that's just me. Anyway, this is how you plot lines, just using base R. Okay, that's it. Have fun.